All right, good evening, my oddly handsome students. We are starting a new unit in chemistry. Woo, we love chemistry. And the unit is called Stoichiometry. And it is a pet peeve of mine when people pronounce it incorrectly, when they call it stoichiometry. Don't mention that to Mr. Beckman because he says it wrong. It's embarrassing. So, stoichiometry is the unit that we're starting. So, I'm going to go ahead and present, and then I'll do a couple things where I show you how to do a few problems. So stoichiometry is a way of combining moles and balancing reactions. We've done both of them. Now we're going to combine them into one. So things we've done so far, we've learned how to convert. We've learned how to go from moles to grams, grams to moles, moles to numbers of molecules, that kind of thing. And that's what we're going to be working with right now. We're going to be converting between moles and grams a lot and balancing reactions. But then we're going to use that to figure out how much of a chemical we need and how much is being produced in the process. So stoichiometry is using balanced chemical reactions to determine the exact amount of chemicals needed or produced in a chemical reaction. It's kind of, a lot of people compare it to having a recipe that calls for, I'm going to make a stupid recipe. Let's say it calls for 1 cup of flour, 3 eggs, and a half cup of sugar. If you have 1 cup of flour, 2 eggs, and a half cup of sugar, how much of your recipe are you actually going to be able to make? Or vice versa, if you have 3 cups of flour, 1 cup of sugar, and 4 eggs, how much of your recipe can you make? And that's what we're going to be doing with the stoichiometry. Some of those ingredients in my analogy are going to be left over because they don't get all used up. Or sometimes you're going to run out of some elements because they do get all used up. And that's what stoichiometry helps us figure out. All right, so how do we do it? Here we've got an equation. The first super important thing, and you have to do that on tonight's homework, is to make sure that you balance all equations. Now we're going to use something that are called mole ratios. A mole ratio is the ratio of the number, in this case, the red number. It's the ratio of the moles of the chemicals needed or produced in a chemical reaction. So for example, in this diagram here, or in this equation here, the hydrogen to oxygen ratio would be a 2-to-1 ratio, or the hydrogen to water ratio would be a 2-to-2 ratio. So that's the mole ratio that we're going to be working with a lot. Okay, so here's our first example. It says, how many moles of CS2 form when 6.3 moles of carbon react? So the first thing that we're going to need to do, like I said, is balance the reaction. On tonight's homework, the balancing is crazy hard. So all the way at the bottom of the worksheet, I just provide you with these red numbers so that you don't have to spend all night just balancing. I want you focusing on stoichiometry and not on balancing. You know how to balance, it just takes time. All right, so we've balanced the equation. That's the first job. And now we're going to go ahead and set up the equation. So you write down what you have. Let's read the question. How many moles of CS2 form? Well, we don't have that. When 6.3 moles of carbon react, we have the 6.3 moles of carbon. So we're going to write that down. And now, just like we've been doing with the mole to mole conversions, we're going to have these conversion factors. There's something's going to go on top and something's going to go on the bottom. And you always want the thing that you're trying to cancel off to go on the bottom. So let's get that written in. So here's the conversion factor, and you're going to put on the bottom the thing that you're trying to get rid of. You're trying to get rid of carbon. And how did we know it was 5 moles of carbon? Because we referred back to the balanced equation. So we see that it's 5C for every 1 CS2s. So then we put the mole ratio of 5 to, give me a second there, to 1, and you put the 1 on top. Now notice that the moles of carbon cancel out because you started with moles of carbon and you put what you're trying to get rid of on the bottom, and they cancel each other out. And you put on top what you're trying to end with. In this case, you're trying to end with moles of CS2, and you multiply them together. 6.3 times 1 divided by 5 gives you your answer of 1.3 moles of CS2. So we have some other example problems. I would strongly recommend pausing my video right now and just seeing if you can do them without me. I'm going to go ahead and do them So you could just be lazy and watch me do them, or you could try to do them on your own just to get your brain working. All right, so here's your chance to pause it. And now I'm moving on. Okay, so I'm going to skip ahead. So the first question was, if you have 7.24 moles of SO2, I don't remember what the question was. How many moles of carbon are needed? So we go back and we put moles of SO2 on the bottom, and we make sure it's 2 to 5. That's the ratio from the balanced equation. Multiply them out, and you get an answer of 18.1 moles of carbon. The next one, you put moles of CS2 on the bottom, and the thing that we're looking for was moles of CO, so we put the moles. Oh, these are all in the wrong order. I'm so sorry. Moles of CO on the top. So I missed something there when I was doing this. I didn't animate it very well, but that's okay. You get the idea. I don't think these are too hard to do at this stage. Now it's going to get a little bit more interesting in just a minute. All right. We have another example here. So we've got a balanced equation, and it says calculate the mass. Well, remember mass is in mass is in grams. So calculate the mass required to neutralize 25 grams of HCl. So it's a 1-to-1 to 1-to-1 ratio. So it seems like we should just write down 25 grams of HCl. It's a 1-to-1 ratio, and we end up with 25 grams of NaHCO3, right? No, unfortunately not. You just went from, let's back that up again. You started with, oops, I'm going the wrong way. You started with grams of HCl and you ended with grams of NaHCO3, but you have to convert it from grams to moles to grams and then back again. So there's several steps required in that, and that's what we're going to practice a little bit. So let's take a look at an example problem that's done correctly. Still a 1-to-1 to 1-to-1 ratio, but we can't skip any steps. So this is how it works. You write down 25 grams of HCl, and in 1 mole of HCl, you write 36.5 grams of HCl. So that's hydrogen plus chlorine makes 36.5. That's where the number 36.5 comes from. How many grams of HCl there are in 1 mole of HCl. Now the grams of HCl cancel each other out, and you've just converted into moles of HCl. Now we're going to use the mole to mole ratio. It turns out that this is just a 1-to-1 ratio, so it doesn't really affect ultimately what you're getting, but you'll see the answer will change in the end. So it turns out that when you multiply it by the 1-to-1 mole ratio, you get 0.685 moles of NaHCO3. But now we've got to convert that into grams. So we put moles of NaHCO3 on the bottom, and we put its atomic mass on the top. And that's with, you get 84 grams when you add 1 atom of sodium, 1 atom of hydrogen, 1 atom of carbon, and 3 atoms of oxygen. When you add those all together, you get 84 grams. That's how much is in 1 mole. And so when you multiply it out, your answer for this question is 57.5 grams. So in summary, things that you need to do, you need to write a balanced reaction. That's the first thing you're going to need to do every time. Convert that into moles so that you know you have your mole to mole ratio, and if necessary, convert into different units. I would like to pause right now. You're going to do stoichiometry worksheet number 1. But I would like to go over maybe a couple problems. I'll just invent some problems in my head, just so you feel a little bit better prepared for worksheet number 1. So I'm going to go try, let's see if I can make this work. If I hit escape, and then I'm going to try squid. And let's see, can I open squid? There we go, perfect. I'm going to fold over my Chromebook, so give me a second while it looks all crazy. You're going to look at my ceiling for a moment. In the upper left-hand corner, I have an equation. 5 carbon plus 2 SO2 makes 1 CS2 plus 4 carbon monoxide. So let's just make up a problem. Let's pretend, let's give you a couple possible problems. So let's pretend, for example, that you have, I just want to make sure I'm on a pen. Yep. Let's pretend that we have, I don't know, 16.3 grams of carbon. And I want to know, if I have 16.3 grams of carbon, how many, this will be our question, how many moles of CO will be made. So what comes from that? So we have 16.3 grams and we need to convert it into moles of CO. So it's going to take a few conversion factors. Even when I'm frozen, what I always do is I write down what they gave me, and then maybe over here I write down what I need. So I'm going to leave it as a blank. That line means a blank. Moles of CO. That's where I'm headed. Now, I may have left myself way too much space. I don't know, but that's a way of doing this. Okay, so I'm going to write down my first conversion factor. I'm not sure where I'm going, but I do know I need to put grams of carbon on the bottom because I do want to be able to cancel out my grams of carbon. And on the top, I'm going to write 1 mole of carbon. How many grams of carbon are in 1 mole? And silly me, I didn't bring my periodic table, but fortunately I happen to remember a few of these off the top of my head. So 16.3, I'm going to switch colors here quickly. 16.3 grams of carbon. Those two cancel each other out. And now we're going to go back. Now we're in moles of carbon, and I could get rid of moles of carbon by putting this on the bottom, moles of carbon, and I want to end up with moles of CO. So here's where I could use my mole to mole ratio from this equation, from this balanced equation. For every 5 moles of carbon, there are 4 moles of CO. So now I've got it balanced, and if you notice, before I do any math, I see that my units cancel out, and the unit that I'm left with is the unit that I wanted. So I know that I'm done doing my conversion factors, and now I just multiply across. So I would do 16.3 times 1, times 4. So I'm going to enter that into my calculator really quickly. 16.3 times 4. And then I divide by anything that's on the bottom. And I have 2 things that are on the bottom. I've got 12.011 and I've got 5. So I'm going to put that in parentheses. Give me a second. 65.2 divided by, and I'm going to go parentheses 12.011 times 5, close parentheses. And then I hit equal, and the right answer is 1.09. Now, just a quick reminder about significant figures. The amount that I started with had 3 sig figs in it. These do not count for sig figs. The mole ratios are always whole numbers. Those aren't measurements. So when we're doing sig figs, they don't count. So the number that I actually got here was 1.085671. And you remember from us doing sig figs that we don't write such a long number. So this one had 3 sig figs, so we give our answer 3 sig figs. Am I going to be super tight and crazy about you doing your sig figs? Not crazy, but you got to start remembering how to do these. So, let's get it figured out. All right, let's try another problem. I'm going to do a pretend problem. Let's say this time we have 32 grams of SO2, and we want how many grams of, no, that's boring. How many grams of CO? There we go. How many grams of carbon monoxide will that make? So I'm starting with grams of SO2 and I'm ending with grams of CO. So that's going to take several conversion factors to get there. So the first thing I'm going to do is draw my line because that's how I always did it. And I'm going to put grams of SO2 on the bottom, and I'm going to write 1 mole of SO2 on the top. KJ, how did you know to put only 1 mole? Isn't it 2 moles of SO2? Wasn't that 2 moles of SO2? When it's moles and grams, when it's moles on top and grams on bottom, or grams on top and moles on bottom, then this number is always a 1. The only time it won't be 1 mole is if it's the mole to mole ratio. If you have moles over moles, that's the only time that it's not going to be 1 mole. Okay, so we're going to add up the grams of SO2, and boy, I don't know if I can do that in the top of my head. I think S is 32 something plus, and then there's 2. So I don't know if this is accurate. I'm doing this off the top of my head since I don't have my periodic table with me, but let's just say 63.998. Now, sig figs, there's only 2 sig figs here. There's just 2 sig figs here. How come I wrote so many sig figs here? I wrote all those sig figs because we don't take sig figs into account until we get all the way to the end, until we get to the answer. So when I added, that's a measurement right there, 63.998. I'm going to write it down as it is, and then I will do the sig figs at the very end. Okay, so what I want you to see importantly is that my grams of SO2 have canceled out. So what do I do next? Well, I know I want to get rid of moles of SO2. So I'm going to put moles of SO2 on the bottom, and I want to eventually get to CO2. So I'm going to put moles of, not CO2, CO on the top. And I'm going to try now the mole to mole ratio. And because I'm using the mole to mole ratio, I'm not going to use the number 1 unless it is a 1. But the moles of SO2 was 2 in our balanced equation, and the moles of CO were 4 in our balanced equation. So now I can see, I was going to change colors when I did that, and I forgot to. These have now crossed off. So now let's continue. I know that I'm going to want to get rid of moles of CO, and I want to get that into grams of CO so that I have the same units on the top that I want for my final answer. So this time, because notice that it is grams and moles together, it's always going to be 1. So 1 mole. If it's a mole to mole ratio, that's different. Here's a mole to mole ratio. We can put whatever the number is in the balanced equation. But when it's moles and grams, it's always going to be 1. And now we need to add up the grams of CO. And what did I say CO was? I didn't say it before. So C is 12.011. plus 15.999 equals 28.01. Hopefully I'm accurate on that. Okay, and now I just need to do the math. So, and I should show you one more time how things canceled off. Moles of CO canceled off, and I'm left with the unit that I'm looking for. So now I'm going to multiply everything on the top, and I'm going to divide it by everything that's on the bottom. So I'm going to do 32 times 1 times 4 times 28.01, and I'm going to do that right now. So 32 times, I'm not going to do the 1, 4 times 28.01 equals divided by, and now I'm going to do it divided by everything on the bottom in parentheses. It's an order of operations issue that is super important. So 63.998 times 2 close parentheses equals. And the answer I get is 28.010875. I see that there are 2 sig figs here, 2 sig figs here. So my answer will have 2 sig figs. 28 is the answer. Ladies and gentlemen, that is how you do stoichiometry. If you pronounce it stoichiometry, I might have to come by and smack you in the face. Don't tell Mr. Beckman I said that. Okay, let me know if you have questions. I would love for you guys to work together on the stoichiometry worksheet for tomorrow. So if you have somebody that you've kind of been working with, contact them, set up a meet, and work together, see what you can figure out. Let me know if you guys have questions. Have a great evening. Bye.